Friends, welcome to today's video in our binary tree series. I'm Chinyele, software engineer at Microsoft here in Dublin, Ireland. And today we'll be solving Leetcode number 101, Symmetric Tree. So get your laptops ready and let's get started. Cheers! The question says, given the root of a binary tree, check whether it is a mirror of itself, that is, symmetric around its center. Hey guys, this question is really simple. Looking at this example 1, the output is true, meaning that it is symmetric. So how do we know that it is symmetric? You see that the left and the right child of the root node are the same, and their children are inverted. That is, the left child here has the same value as the right child on the other side, and the right child here has the same value as the left child on the other side. You can see that this is different for example 2. The output is false because while the left child on this side is null, the right child here has a value, so they are not the same and therefore are not symmetric. Now, how do we solve this? We will start by initializing our results variable to true. So our tree is symmetric until proven otherwise. We now use a recursive function to traverse the tree to check if it became asymmetric at any point. Our function will take two variables, the left child from one side and the right child from the other side. And then we will have a couple of base cases which are conditions that, if met, will terminate the function. And these conditions are 1. If the two nodes are null. So if the two nodes are null, we simply return because this means we just hit the leaf nodes and there is no point moving forward because there is nowhere to go to anyways. The next condition that will make us terminate this function is if we find anything that makes the tree asymmetric. And these conditions are if node 1 is null, or node 2 is null, or the value of node 1 is not equal to the value of node 2. So what this means is that if node 1 is null and node 2 has a value, we terminate the function. If node 2 is null and node 1 has a value, we terminate the function. And finally, if they both have values, but their values are not the same, we equally terminate the function. So of course, when this happens, the tree is no longer symmetric. So we set our result value to false and return. But if this condition was not met, our tree is still symmetric. So we can continue our traversal by calling this same function using the right child of node 1 and the left child of node 2 as the input variables, and also call the function using the left child of node 1 and the right child of node 2 as input variables. Finito. To begin the traversal, we call this recursive function passing in the left child of the root node and the right child of the root node. And at the end, we return the result. Simple. Let's run and submit the code. Good job! The time complexity of this solution is O of n, where n is the number of nodes in the tree. This is because the DFS is called for each pair of nodes in the tree exactly once. And at each level, the function does a constant work by comparing node values and making recursive calls. For the space complexity, we use the constant amount of memory to save the variable result. And we also use a recursive function which has a call stack that in a worst case scenario has a depth of n, where n is the number of nodes in the tree. So therefore the overall space complexity of our solution is O of n. I hope this is helpful. Thank you for watching until this point. If this video was helpful, please give it a thumbs up and hit the subscribe button to see more videos like this in the future. Thanks again for sticking to the end and see you in my next video. Bye.